What really happens when galaxies first form? Not a gentle unveiling, but a cosmic struggle in the dark, where gravity sculpts, gas fights back, and the first light claws its way through a fogged universe. After the Big Bang, the universe expands and cools. Hundreds of thousands of years in, electrons meet protons. Space turns transparent. Then comes a long night. Neutral hydrogen fills the cosmos. No stars yet, just gravity, patient and relentless. Tiny ripples in density, imprinted in the primordial plasma, grow. Dark matter, invisible but massive, collapses first, weaving a cosmic web. Filaments feed knots. In those knots, halos form, deep gravitational wells waiting to catch falling gas. Gas streams along the filaments and plunges into the halos. It heats as it falls, then cools by shedding light. Atomic hydrogen lines, then molecules, carry away energy. As it loses heat, the gas spins up, conserving angular momentum, beginning the hint of a disk. Cooling brings fragmentation. The cloud breaks into dense clumps. In their cores, pressure wins. The very first stars ignite. Population 3, titans of pure hydrogen and helium. Fierce, blue, and short-lived. This is the era around redshift Z(20) down to Z(10), roughly 1 to 500 million years after the Big Bang. The universe is young, the structures are small, but growth is furious. Those first stars die fast, some in colossal supernovae. They forge heavier elements, metals that seed the gas. With metals, cooling becomes easier. Stars can form smaller, longer-lived, and more numerous. The galaxy's chemistry awakens, but feedback hits hard. Intense radiation, stellar winds, and supernova shocks blast gas outward, carving bubbles and shells. Star formation throttles. The galaxy coughs, then gravity pulls the ejected gas back. It cools, rains in, and lights new bursts. Outflow, fallback, repeat. This cycle, self-regulation, is the heartbeat of young galaxies. Some systems begin forming protodisks, flattened, rotating structures, while others stay turbulent and clumpy, their gravity stirring chaotic starbirth. Order emerges and unravels all at once. Growth is not solitary. Mergers dominate. Two proto-galaxies approach, tidal tails unfurl, and in the violent embrace, gas compresses, triggering starbursts that outshine entire galaxies. These starbursts forge stars at frantic rates, enriching and stirring the medium. Dust forms, light reddens. To a telescope, they look compact and blazing, small bodies with oversized brilliance. In some hearts, black hole seeds appear, either from the deaths of massive stars or direct collapse of dense gas. They feed. An accretion disk blazes. Jets punch into space. Somehow, by ZAP-6, some black holes reach 1 billion suns. Their quasars flood the cosmos with ultraviolet light, carving ionized bubbles in the hydrogen fog around them. Reionization spreads, patchy at first, then widespread. The fog lifts, the universe becomes transparent again, and the young cosmic web shines through. This is why JWST often sees tiny, bright, clumpy galaxies. Small halos, furious assembly, intense feedback, and rapid fueling along filaments, all packed into compact volumes of space and time. With time, gas supply steadies. Turbulence wanes, rotating disks settle. Spiral arms organize starbirth into patterns, waves of density sweeping through a cooler, calmer medium. Others take a rougher path. Major mergers scramble disks, puffing stars into orbits that form massive ellipticals. Older, redder, and quieter. Even then, inflowing gas from the web can keep feeding growth. Bars funnel material inward. Slow accretion builds thin disks. Bursts flare when streams collide. Star formation is never perfectly efficient. Often only a few percent of gas becomes stars per dynamical time. Feedback keeps the thermostat set, preventing runaway collapse. In every young galaxy, it's a negotiation. Gravity pulling in, pressure and light pushing out. The shape you see is the truce they reach, for now. We are learning this language, mapping filaments, weighing halos, timing bursts, tracing metals, and listening for the winds that breathe galaxies in and out. From the first sparks to the grand forms, assembly is messy, magnificent, and precise. Physics written in starlight, terror and beauty share a border. On one side, collapse. On the other, creation. Galaxies live on that edge. With JWST today and giant telescopes soon, the map sharpens. We're catching galaxies in the act, measuring their fuel, and watching the truce evolve. Because galaxy birth isn't a legend, it's a problem set. Hard, but solvable. Piece by piece. Follow the filaments. Weigh the halos. Track the light. The first galaxies are still speaking. We're finally close enough to hear.